Our next topic is on the difference quotient. This is actually another rate of change. It's actually a more generic way to measure the rate of change than the other ones that we've been looking at. And essentially it finds the slope between the points with the x-coordinates x and x plus h. So you'll notice here that we have a couple parts to this. This is the function with x plus h plugged in. This is the function just with x plugged in, or you could say the original function. So we're going to subtract those and then divide by h. So just to kind of talk about where this comes from, the slope formula, y2 minus y1, x2 minus x1. I mean, if you have 2 points on a line, then you have, let's say, x1 and y1, and you have x2 and y2, and that's your slope formula. So let's say if we have the points like it's talking about, x and x plus h, let's say those are our x values. So the y values for this would be f of x, and the y value here would be f of x plus h. And you can see that that's really where our formula comes from, because if you just take make it look like the slope formula, you're taking your y value, f of x plus h, minus f of x, and over that you would do x plus h minus x, and you'll notice that those x's cancel out. So you would just have f of x plus h minus f of x all over h. So that's kind of a background on the difference quotient. It's very important for calculus. So if you are taking Calc 1, you will definitely see this many times in like the first half of the semester, and kind of always. Okay, so they want us to use the difference quotient for a couple of specific problems. So here, I'm going to make a lot of parentheses. So they want us to have f of x plus h. So this is the function with x plus h plugged in. So I'm looking at that part of it. So that's going to be, if I look at my function and just plug in x plus h wherever I see x, it will be 5 minus 2 times x plus h. Then I want to have the function with x, or you could just say the original function, and I'm getting that from this part of our difference quotient. So I'm really just copying the original function here. And from here, it's a simplifying problem. So if I start distributing, this will be 5 minus 2x minus 2h. And then I want to distribute that negative sign, so it would be negative 5 plus 2x. This is all over h. And a lot of stuff will go away. This will be negative 2h over h, because these go away and these go away. And that will be equal to negative 2. Now, this should make sense because our original function was a line with slope negative 2. So that's good that it is consistent with the slope. They won't all be like this. Most of them are not going to just be lines. They're going to have some quadratics or maybe more. But for here, it's kind of nice to see that it actually does give us the slope.